Hello and welcome to Parsons 101 training presentation for the Lamella. My name is Michael Cole and I'm the product manager for the Lamella. So my agenda for today is to just talk about the Lamella gravity settler, some of the basics of the equipment, talk about Parsons' experience. I'm going to talk about the two kinds of Lamellas, which is the LGS and the LGST. I'm going to discuss EcoFlow and then some of the benefits of EcoFlow. So this is what a typical Lamella looks like. Obviously there's a number of different models, but this is one particular model that has two plate packs. But the flow will enter into first the flash tank, where we have rapid mixing occurring, where we're activating our coagulant and polymer. And from there it goes into a larger flocculation tank, where we slowly agitate it with a rake, which you can see here, to grow the particles in size. Those particles in the water then go through a feed duct, which enter the feed box, which is positioned between two plate packs in this case. The flow from there flows down the feed box and enters a series of feed slots at the bottom of the plate. And the clarified water then flows to the top of the plate and enters a series of orifice holes. There's 2 holes per plate into a discharge flume, goes over an overflow weir, and then the overflow goes through the pipe in the outlet nozzle and becomes clarified effluent. The solids slide down the plate and collect in a sludge hopper for the LGS. I'm going to discuss the LGST later on. And that sludge then goes through an underflow sludge pipe. So the plates in the Lamella are all arranged at a 55-degree angle to promote solids movement. Previously, Parsons had produced Lamellas where the plates were at a 45-degree angle. But we found that solids would tend to get stuck and hung up on the plates. So in order to promote solids from moving down the plates and preventing solids hanging up, we increased that angle to 55 degrees. The projected plate area, if you look at the space that the plates take up when the plates are on a 55-degree angle, is actually about 57% of what the total clarification conventional clarifier would be had those plates be horizontal. So because of this, the Lamella takes up quite a bit less footprint space in a plant, 57% less, and that's why many of our customers choose a Lamella over a conventional clarifier, because they don't have the space required for a conventional clarifier. The plates are spaced at 2 inches apart from each other, and that's to accommodate high solid concentrations. We did previously try plates that were spaced 1.5 inches apart from each other, but because of some of these higher concentrated solutions that we clarified, we tend to enter hindered settling at that spacing. This is what a typical Lamella looks like from the top view. You can see this particular Lamella actually has 3 sets of plate packs. So there's 1 discharge flume above each plate pack. And as I said before, there's 2 holes over each plate. There are 2 feed ducts. Each feed duct feeds 1 feed box. And the flow will go up the plates through these holes, go over this weir. So there's 1 weir per discharge flume, collect in the overflow box, and then go out the overflow through this outlet nozzle. So Parsons actually has about 41 years of experience with the Lamella. So it's not a new product by any means. The product essentially remained unchanged until about 2012 when we introduced EcoFlow, which I'm going to discuss here in a little bit. We have over 4,800 installations. I believe it's a little close to 5,000 at this point in both municipal and industrial applications. The first type of Lamella is the LGS, which stands for Lamella Gravity Settler. And this is actually identical to the cross-section of the unit that I showed you previously with the hopper or conical bottom. And in this type of configuration, the sludge just collects in a conical bottom. There are no moving parts down there. The sludge just collects and then gets concentrated somewhat and then flows out the underflow nozzle. There are models that range from a 75 up to a 3900. And these numbers correspond to the projected plate areas. If you remember before, I had mentioned that the plates, when they're on an angle, will give you a projected amount of surface area, and that's what these numbers correspond to. The LGST, or the Lamella gravity thickener, you can see looks a little bit different. It has a cylindrical bottom, which acts as the sludge collecting tank. And inside this tank, you can see in the image on the bottom right of the slide, there's a rake that slowly agitates the sludge, and what it's doing is it is coaxing the water that's trapped between the solid's particles to escape, and therefore we're able to get higher sludge concentration compared to the typical LGS, about 3 to 5 times more concentrated. And this sludge tank also has more holding capacity in terms of sludge compared to an LGS. And these models range from a 360 up to a 3915. This is what some typical municipal installations look like in terms of size. You can see we have a large one in Cincinnati, which is 175 million gallons per day, all the way down to smaller, and actually we have much smaller ones than this, even this Roaring Creek one. It should be noted that industrial applications will typically have smaller size installations than these municipal ones do. So in 2012, Parkson released an innovation to the Lamella called Lamella EcoFlow, and I'm going to go over briefly what that is. Before we introduced EcoFlow, we actually had what was called the 80-20 design in terms of our plate configuration, and what that meant was that only 80% of the plate was actually usable for settling solids, and 20% was rendered ineffective. And the reason for that was because of the configuration of our feed slots. This diagram shows what the feed slot configuration looks like on the bottom portion of the plate. And the feed slots were actually orientated on the bottom part of the plates. And what happened was the influent would enter the feed slots and mix and disturb the sliding of the solids sliding down the plates. And it basically had 20% of the plate was acting like this turbulent mixing zone. When we introduced EcoFlow, what we did was we orientated these stiffeners, which is these pieces of plastic which actually make these feed slot holes on the sides of the plates. And we rotated that 180 degrees so the feed slots are now on the top portion of the plates. And by doing that, we're actually shielding the solids as they slide down the plates from the incoming influent. So we no longer have that 20% of the plate acting as a turbulent zone. So we're getting 100% effective use of the plate for settling. And next I'm going to show you a short video which explains this.
On a horizontal surface. The original Lamella could only use 80% of the total plate surface area. This is because the path of the influent flow collided with the solids moving down the plate, causing a zone of turbulence that cannot be used for settling. This 80-20 split is the current industry standard when sizing a plate settler. To overcome this phenomenon and achieve 100% use of the plate area, the flow at the feed slots needs to be redirected away from the solid settling path. In order to improve the design and allow for full utilization of the plate settling area, the feed slot location was mirror imaged to be on the bottom of the plate instead of the top. This minimized the disturbance caused to settling solids, allowing for the use of 100% of the clarification area available. Parkson performed a full-scale pilot test to validate the design and produce a comparison of the two models. This is the original 80-20 design. Here the turbulence is evident from the influent mixing with the solids traveling down the plate. And here is the video of the innovative EcoFlow design. Feed enters at the sides of the plates. Solids slide down the plates without disturbance and drop into the sludge hopper. Sludge re-entrainment is avoided by segregating the feed and sludge, permitting the existence of two laminar flows.
So since EcoFlow was released in 2012, Parkson sold about $15.7 million in EcoFlow sales, and that includes 27 new customers and 159 rebuild, retrofits, and parts customers. And this is very impressive, especially in the difficult economic times and down market which we've seen in the last few years. So just to reiterate, the features of EcoFlow and the benefits, there's no zone now of interference between the feed solids and effluent, which allows higher quality effluent and enhanced sludge thickening. We now get 100% utilization of the plate settling area, which gives us at least a minimum 25% capacity increase through an existing footprint. We have had customers that have actually seen even closer to 50% capacity increase. And this relatively simple feed port change, which leaves the rest of the plates unchanged and the tank unchanged, means that our previous non-EcoFlow installations can be easily retrofitted with EcoFlow plates, which is very good for our aftermarket business.